And I have to say, when I was a young boy, 16 years old, your father-in-law basically was my master. I got my electronic training at the age of 16 in Huntsman Electronic, in Basinghausen, in Germany, while still in high school. And this was before I entered university, but gave me the practical insights of power electronics. And the skills I acquired at that time still help me every day today. And we're very happy to continue this tradition for such a long time.
Yeah. And also right now, Florian is giving everything back, so to say. So back in the day, Frank Huntsman, who was the founder of Huntsman Electronic, was the mentor of Florian. And nowadays, Florian is kind of the mentor of me. So we're kind of closing the circle, so to say. So power electronics is electronics like you have in your computer, but they are meant not to control information like normal electronics, but they are meant to control power. So if you have some mains output from the wall socket maybe, and you need to charge your phone, you need some ways to convert the power from AC, from the wall outlet, to DC to charge your battery. So we are surrounded by power electronics, our cell phone chargers, our electric cars, our solar plants, everything needs power electronics these days. And also in our field, we needed to drive special lamps, which require certain characteristics in the output. And that's where we need to convert again the power coming from the mains, from the generator, to a certain waveform for the lamps.
Or to say it in other words, power electronics are all around you.
Yes.
And if you're not in that field, you usually take it for granted. But if it's not there, it's a pretty dark, cold, boring, quiet place.
Yes, dark and boring. No internet, no computers, nothing. There are two separate markets, as always. You have the mass consumer market, and you have the industrial or medical special market. And the last one, the special market, will have certain requirements which cannot be fulfilled by the mass-produced products. So, of course, there are Chinese versions, and there are good Chinese versions, to be clear. But in the niche market, where also the quantity of items you need is not so large, there's not so much of advantage for mass production. So you need a smaller company with a highly specialized focus, providing high quality, the good support they need, because in the medical sector and industry, they need close support. And that's what we are good at, basically.
I would just say it this way. It's not about good or bad. It has to be fit. It has to fit the purpose. So if you are sitting on a dentist chair, the light that you need needs to serve the dentist to get your teeth right. And that's a very different requirement than if you're going to a pub and have a drink and have a light on top of the bar. So I would say rather than good or bad, I would rather say fit the purpose. And what we have been promoting for all this time is we are making special light for special purposes. And we need to adapt our power electronics to fit the purpose of the user. So again, it's not about the power or the product itself. It's about getting it right at the right application. And that is often not properly served by the mass market.
Can you just quickly explain what are the special needs of a dentist? Because from my perspective, a light is a light, and I can see or I cannot see.
Yeah, but let's be specific for the dentist. Most people go to dentist to get their plug removed, all right? And maybe if you've been to dentist, sometimes they ask you to take a special liquid to show the plug. And it shows up in red or in blue. And like in the dentist light, there is also some UV component. So that particular reflects to this chemical that you take to show your plug, so that the dentist can easily find your plug to remove it. So that light would need to have this. Yeah, that would be one of example. Or if you get a filling, you need to cure the filling in your teeth. So sometimes they go in with a little needle, with a little blue light, to go exactly onto the point where they put the filling in. This is also an example for a special light source for the dentist. And then they push a button, and then the light will not stay on forever because it will hurt other tissue, so it will go off automatically. So this is a special light for curing a filling in your teeth.
Now, Huntsman is responsible for the power electronics for special lighting, or also the special lighting?
So we work together with the major lamp manufacturers, because the lamps itself are, for me, they're like a work of art, because it's like the glass tubing, which is highly specialized quartz material, and then they have the electrodes, which are precision manufactured, and then they need to put in the gas mixture and so on. So that's out of our realm, so to say, because that's really, really involved manufacturing. But there are companies like Osram and Oshio from Japan and so on. And these usually work together with us. And so if a customer has an application, he usually will buy a lamp fitting this application. And then the ideal path is that he is requesting the lamp manufacturer for a power supply, and they work together with us, and we can supply the products.
And then comes the application requirement. So it's not just the lamp, but it's also the application requirement. So if you like, for instance, on a camera, you want to have a very stable lamp. If it's an AC lamp, you may want to synchronize it with the camera. So it's the lamp, it's the application, and then the power electronics to make that a fit. And that's normally a bit out of the ordinary in a way. But as you can imagine, the guy who's blowing the glass may not be so good in power electronics. And we, as we do power electronics, we're not so good at blowing glass and sealing metal inside. It's not our expertise.
Never tried it, but...
So then maybe you can quickly share, what is your expertise, Leon and Florian?
So power electronics is quite a wide field because you have the power electronics itself, which is, of course, a complicated topic. You need to handle analog design, which is quite different and not so much seen these days. Over the last decades, we've seen a lot of shifts to the digital realm. You just use a microprocessor, a microcontroller, okay, cheap, easy, firmware programming, and then you're done. But for power electronics, you also need to look in the analog world, and you need to bring these two together. So you need to be good at analog design, digital design. You need to consider the electromagnetic interference because we don't want to disturb other electronic equipments. And then you need to have a look at manufacturing. So it does not stay at the point that you have just a good design. You need to be able to manufacture it in a reliable and reproducible way.
And you need to consider the thermal environment because power electronics, especially when the lamp is hot, you will create heat. And when you make an equipment, no matter what it is, you have to think about where the heat goes. That means the power electronics itself does not like to be treated too hot. It's one thing. Second, it also emits heat and it has to get rid of the heat. So not just the electronic design, it's also you have to consider the thermal design and not just of your power supply itself because you cannot completely treat this as an independent issue. You also have to consider it in the application. And I think everybody is aware that when you have a computer, like a desktop computer, you often hear those fans running, right? Well, ask anybody taking videos whether you would like to have fans running in their video, and they will probably tell you not so much. So for instance, if you have light sources, which are in combination with the need for quiet environment, that's another challenge that has to be addressed.
Yeah.
And when this is a higher power, then this is not so easy. When this is a cell phone power, okay, fine. 5, 10 watt, not big deal. When we talk about 200, 300 watt, it's a different story. When we talk about 1000 watt, very different story.
Yeah. So basically it's like electronic, physics, mechanical, sourcing of material, manufacturing, quality,
Control.
quite involved.
And it sounds like your designers and engineers have to make compromises about size, sound, weight, all of these.
Yeah, so when I was at university, when I was at a research institute, it was about testing new ideas. And then you make your power electronics design, and it doesn't really matter what the form is or what the size is or how you can manufacture it. And that's what you need to learn if you go to the real world. Can I fit into the application space? Can I fit into the application environment? Maybe I have an environment with a high heat, high humidity. So there are a lot of real-world factors you need to combine. And then especially if you go to heavy regulated environments like server racks and so on, or computer farms, you need to have the high efficiency. So there are a lot of things to consider. But this is different for every application.
Yeah, and then if we don't have enough regulation by now, you can be sure that the European Union or the American regulator will come up with new regulations anytime soon. So if you think you're ready, by the time you're ready, soon there will be a new regulation that you haven't met or considered yet, and then you start all over again to put that back in.
Yeah, especially for medical equipment, we have a lot of power supplies in the medical sector. And there, of course, you have very stringent requirements for safety, right? You don't want to have electrical shocks or explosions or smoke to the surgeon or to the patient. So
Right.
Safety requirements are also a big deal for us, which are very important and very time consuming.
For instance, also about risk assessment. If you make a surgical equipment, like endoscopy equipment, where you have like a light going into the body from one hole and you have a knife going in from the other hole, what happens if the light goes off while the knife is in your body? That's not such a pleasant imagination. So in the design of that medical equipment, you have to plan for that scenario and you have to consider this. Or, as you mentioned, you don't want to have your equipment going up in smoke while you have an open wound next to things. So these things, are usually not considered in, I would say, general lighting applications in your ceiling light, but these have to be considered in a medical equipment. And so the power supply has to give the necessary feedback to detect, for instance, that a lamp actually has gone off. So there are parameters which are not very obvious in the beginning, but when you enter the specific field, these requirements come up. And Huntsman Electronic is an ideal service provider to support those equipment makers that do not have their own power electronic skill, but need to meet specific requirements in that application.